Okay, welcome back. This video is going to cover everything relating to percent composition, specifically how to calculate the percent composition of each element of a compound. A thing to remember about percents, ladies and gents, is percents are calculated by taking the part, dividing it by the whole, and then multiplying it by 100. And that'll get you the percent that each part is made of. In this case, the part is each of the masses contributed by each of the elements, and the whole is the weight of the entire compound, also known as the molar mass. So the first thing that we have to do when we calculate the percent composition of a compound is we have to calculate the molar mass, and we have already been calculating the molar mass for a few days now. Okay, and just in case you need a refresher, the molar mass is the number of each element present in the formula. For instance, there are 6 carbons, multiplied by the weight of carbon, or the molar mass. Same thing with hydrogen. There are 12 hydrogens present, multiplied by the molar mass of hydrogen, and that'll get you the total weight of hydrogen in this formula. Then again, for oxygen, there are 6 oxygens present, and the weight of oxygen is 16. Multiply those together to get you the total weight. Add them together, and then you get the molar mass, okay? So to calculate now the percent that each element contributes, for instance, the percent carbon in this formula, we will take the part, which is 72.06, divide it by the whole, which is the molar mass, and we'll leave the grams per mole off because those will cancel, and then we multiply it by 100, and that'll get us the percent carbon. I'm not going to solve it right now. I'm going to set everything up first, then we'll go through and solve. Let's set up hydrogen next. The part is 12.12 divided by the whole, 180.18, multiplied by 100, and then that will get you the percent hydrogen. And then lastly, for oxygen, the total weight contributed by oxygen is 96, divided by the total molar mass, multiplied by 100, and that'll get you the percent composition for that oxygen now. Alright, let's go ahead and go through and calculate these. So we have 76.06 divided by 180.18 multiplied by 72.06. I typed that in wrong. 72.06 divided by 180.18 times 100 is going to get you 40%. Then for the next one, we'll look at 12.12 divided by 180.18. Multiply that by 100, and that's going to get you about 6.7%. And then for oxygen, we'll do 96 divided by 180.18. Multiply by 100, and that's 53%. If you add these percents together, you'll come up with 99.7%, which is essentially 100, and that's a good way to check that you did this correctly. Let's go over the next example. Again, very same idea, in fact, the exact same idea, except you need to calculate the molar mass first, and then we can go through and do the percentages. I've gone ahead and calculated the molar mass already because I assume you know how to do that. And just remember that it's always the part divided by the whole times 100, and that gets you the percent, okay? And again, each of these elements' weights, or total weights, are the part, and then the molar mass is the whole. So let's go ahead and figure out hydrogen in this case. And so hydrogen contributes a total weight of 1.01, and the molar mass is 100.46. Multiply that by 100, and that'll get us the percent hydrogen. To get the percent chlorine, the total weight that it contributes is 35.45. divided by the molar mass, 100.46 times 100, and that'll get us that percent there. Then for the percent oxygen, we've got 64 as the total mass it contributes. We'll divide that by 100.46 molar mass times 100. And then we'll continue on with our calculation. Okay, 1.01 divided by 1, type that in wrong, 1.01 divided by 100.46 times 100 is going to be 1%. 35.45 divided by 100.46 is going to be times 100, 35%. And then 64.00 divided by 100.46 is going to be equal to 64%. And if you add those up, you should get exactly 100%. Okay, so those are the basics right there of calculating percent composition. Remember, the first step is to always calculate the molar mass. Okay, and I would calculate it this way, the way I have it out right here, because that's going to help you see what the different parts are that you're going to need to divide. All right, so go ahead and work through the example problems, and we'll see you in the next video.